You might wonder how game cheats are made, if they're really considered hacking, and why they're so common despite being specialized for both cheat and game developers. This video will explain how game cheats work, how they're made, and give examples. Game cheats vary in form, style, and format, but they're designed like any other program. They have a front-end, a back-end code base, and features like security and design elements. However, game cheats differ from regular game plugins because they exploit vulnerabilities that most developers are unaware of, don't care to fix, or are still patching. The first step in developing a game cheat is to find a vulnerability within the game's executable file, exe, or a dynamic link library, DLL. This process involves several techniques. Reverse engineering uses tools like IDA Pro, Ghidra, or OllyDbg to disassemble and analyze the game's binary files. By examining the assembly code, developers can identify weaknesses in how the game handles data. Dynamic analysis involves running the game in a controlled environment and monitoring its behavior with tools like Cheat Engine. Developers look for unusual memory usage patterns or other anomalies that indicate potential vulnerabilities. Code injection involves using methods such as DLL injection to insert custom code into the game's process to manipulate its behavior. This step often requires bypassing security mechanisms like ASLR, address space layout randomization, and DEP, data execution prevention. Once a vulnerability is found, the next step is to identify specific memory addresses that store important game data, such as player health, ammunition, or position coordinates. This process involves memory scanning, where tools like Cheat Engine are used to scan the game's memory for specific values. By changing these values in the game and observing the results, developers can pinpoint the exact memory locations. Pointer analysis is used because simple memory addresses often change between game sessions. To find stable addresses, developers use pointer scanning to trace back from the found values to base pointers that remain consistent. Memory mapping involves creating a map of important memory regions and their corresponding values, serving as a reference for manipulating game data. After gathering the necessary memory addresses, developers plan the cheat's design. There are two main types of cheats: internal and external. Internal cheats are injected directly into the game's process, offering direct access to game functions and variables, efficiency, and complexity for sophisticated features like aimbots and wall hacks with high precision. However, they are more complex to develop and easier for anti-cheat systems to detect. External cheats run as separate processes alongside the game, interacting indirectly by reading and writing memory. They have a lower detection risk and are simpler to develop, but they are generally less efficient and powerful. Writing the cheat code involves several steps, each with its own challenges. Choosing a programming language is crucial, with most cheats written in C or C++ due to their low-level memory manipulation capabilities and performance. Other languages like Python or C# may be used for specific tasks or tools. Creating memory modules involves handling reading from and writing to the game's memory using functions like open process, read process memory, and write process memory. Implementing hooks extends or modifies the game's functions, including inline hooks that modify the game's code directly, VT-able hooks that manipulate virtual function tables to intercept function calls, and IAT/EAT hooks that modify the import-export address tables to change function pointers. Developing cheat features depends on the cheat type, with internal cheats implementing sophisticated features like aimbots and ESP, extrasensory perception, and external cheats focusing on simpler yet effective manipulations. Testing and debugging are essential to ensure the cheat works correctly and remains undetected, using tools like X64DBG to identify and fix issues. Anti-cheat systems work by monitoring game files to ensure they haven't been altered or replaced by cheat programs, analyzing player behavior for unusual patterns that may indicate cheating, consistently hitting impossible shots, scanning the player's computer for known cheat programs or unusual processes running in the background, and implementing server-side checks to detect and prevent cheating in real time. Hackers use various techniques to avoid detection by anti-cheat systems. One common method is obfuscation, where hackers hide their cheat programs by encrypting or disguising them, making them harder for anti-cheat systems to detect. For example, a cheat program might rename its files to look like harmless system files, or use complex encryption to make its code unreadable to the anti-cheat software. Another technique is memory manipulation, where cheats modify the game's memory while it is running, allowing the hacker to change game data without altering the actual game files. Some hackers use kernel-level cheats, which run at a low level in the operating system, making them more difficult for anti-cheat software to detect and remove. An example of this is a kernel-level aimbot that intercepts the game's aiming function and modifies it to always aim perfectly without being detected by user-level anti-cheat programs. Additionally, hackers create custom versions of cheat programs that are specifically designed to evade current anti-cheat detection methods. For example, if an anti-cheat system updates to detect a specific cheat, hackers might modify the cheat to change its signature or behavior so it no longer matches the detection criteria. If you're curious about how hackers crack passwords, click the video on the screen.